these last two rules in my log tables we want to have a look at. So it's a to the power of log x in the base a is equal to x. Where would I get a question where I could use that? Well, it might not be very likely that it will turn up as often as the other rules in your log tables, but it would look something like this, okay? And the reason that this rule works is because logs and indices are opposites of each other. They're the inverses. So if you have a sum where you have x plus 5 is equal to 10, well, you use minus 5, the inverse of plus 5, to work with it. Same with if you have 2x is equal to 12, you'll divide by 2 because they're the inverse. So we have the inverses are plus and minus. We have multiply and divide. You have sine and inverse sine, tan and inverse tan. You have loads of inverses. And here, in this rule, logs and indices are the inverse of each other. And this is why I can just write that using that rule, I'm left with x equals 5. Okay. So it's probably not going to come up that often, but it is a handy rule if I see something like this. And I just go to my log tables and see is there a rule that I can apply. This rule then is your change of base formula. It's very easy again if you just carefully fill it in. Why do I need a change of base formula? Well, all the rest of my rules are to do with being in the same base a lot of the time. So I can't apply a lot of the other rules if I don't have the same base. So if you had a question like this, where you're working in two different bases, I would maybe take this one and change them both into the base 2. Now this one is fine, it's in the base 2. So I need to go to my log tables, and using my formula I need to carefully, so log of x in the base b. Now my new base we'll call a, so it's log of x in the new base over log of the old base in the new base. So log of this in the new base all over log of the old base in the new base. And now everything is in the base 2, and I should be able to just work with my question. On the top line here I can't do anything with that, but on the bottom line, log of 4 in the base 2 is 2 is equal to log x minus 1 in the base 2. And here I'm going to bring the 2 over, it becomes multiply, or I'll multiply both sides by 2. I'm going to use my inverses. And when I multiply this side by 2, I can see here that now I can apply another rule. It's the third rule that we looked at here, where if I have a number in front, I can bring it up and it can become a power. So that's equal to log of x minus 1 in the base 2 to be squared. And now I can just use my identities, or just looking that this must be equal to this, dropping my logs in the base 2. I end up with 3x plus 1 is equal to x squared minus 1, x minus 1 to be squared. I end up with 3x plus 1 is equal to, you can take that to the side and square it out carefully, you end up with x squared minus 2x plus 1. Bringing everything to one side, you end up with x squared minus 5x equals 0. And then I'm going to take x out in common, and left it x minus 5, and then I'm going to let each factor equal to 0, so I end up with x is equal to 0, and eventually I end up with x is equal to 5. Now I need to always check here, and if I was to go back to the original question and let x equal to 0, that would be a plus number, which is fine, but this would not. And I cannot have either a base or this number be a minus number. So I'm going to cross off the x equals 0. It's not a possible solution in this question. And I can check the x equals 5. Again, that means that this would be a plus number, that's fine, and this would also be a plus number, that's fine, and my bases are plus numbers. So my only solution is x is equal to 5. Now, so they're the rules. The worst, or the hardest possible question I could probably get with a change of base question would be something like log of x in the base 3 plus 3 log 3 in the base x is equal to 4. I need to take one of these. I'm going to take this one here and I'm going to change the base to log in the base x. So I go to my log tables and I follow my formula carefully, and it's log of x in the new base all over log of the old base in the new base, plus 3 log 3 in the base x is equal to 4. This, so if it was log 5 in the base 5, log 2 in the base 2, I'd end up just with a 1 up here all over log 3 in the base x, plus, again I'm going to apply the rule where if I have a number in front I can bring it up and it can become power, log 3 to the power 3 in the base x is equal to 4. Now I may not want to apply this rule. You know, I might be better off leaving it like this, because if I look here and if I don't apply that rule, it might allow me to do some substitution here, because I'd be left with an equation where I'm looking to solve for x. So I could decide here, right, I'm going to try and make my life a bit easier and go, I'm going to replace log 3 in the base x with a y. And if I solve for y, I'll eventually then solve for x. So I end up with 1 all over y plus 3y is equal to 4. I'm going to multiply both sides. I'm going to multiply everything by y. So I end up with 1 plus 3y squared is equal to 4y. Now, that's a trinomial. I'm going to bring everything to the left and I'm going to work it out, and I'll eventually, so I'm not going to do this, so I'll eventually end up with y equals 1 or y equals a third. Now, I'm the one who introduced the y, so I need to go back and get x. So log of 3 in the base x is equal to 1. And I can work that out, and log of 3 in the base x is equal to a third. I can take this out of log format and work out that x is equal to 3 and x is equal to 27. So by taking it out of log format, it's x to the power of 1 is equal to 3. Well, that must be x is 3. And x to the power of a third is equal to 3. Well, that must be 27. X must be 27. And that's probably the trickiest question that I could get to do with a change of base question.